Today we are going to discuss on a particular problem, that is one chapter that is on friction. Okay, what is basically friction? Friction means it is nothing else but when there is the movement of a body or one body tries to move in a particular direction, then there is the friction which tries to resist the very movement of the body. Okay, that is the main part. So now how to identify or how to make this friction particular plane. Say there is one plane, say this is one plane, and on that particular plane, let us say there is one member or one object is there, and here we have the load which is mg, that is the weight of the body which is acting downward on the plane, and so there is one normal reaction force which is basically acting in the upward direction. Okay, and now if there is one force we are providing here in the say right hand direction, then almost what happens, the body tries to move in that particular direction. But there are two conditions. One is the body tries to move but it can't able to move in that direction. So how much time it will not move? That means up to the limit this particular surface tries to make it in a static condition. So what happens? There must be one resistive force which will act at the contact surface between this particular member and there is the say plane, or we can say that is another floor. So if there is the floor and there is the member, then in between there is one surface which is the contact surface between these two, and along the surface opposite to the direction of its motion, not only its motion but its tendency to move. When there is the tendency to move for the movement of the body, then in the opposite direction there is the activation of this frictional force. That is very much important part, that is the frictional force. Okay, now this frictional force, how it basically acts? Basically what happens, if I look to this particular part, there are many undulations in the lower part as well as in the upper part of this one. So that means if we go to the microscopic part of this, we will see there are much more many undulations, microscopic view, and these particular undulations ultimately make them lock between each other, and so when they lock with each other, then there is the movement of that particular body is being resisted by the surface itself. So mainly that is the reason for which there is a frictional force. But this frictional force is not basically dependent upon the surface area which are in contact with each other. That means it is not dependent upon the surface area. Now what happens? This frictional force is proportional. This is proportional with the normal reaction, and we know from our force on Newton's force that if there is one action, that is the here in this particular case the weight which is acting on the floor, and so there is the reaction, the floor is providing the normal reaction on the material or the object. So these two are action and reaction, and they are acting on two different bodies. One is on the plane, another one on the member or the block, whatever may be. And here the calculation is dependent upon this one. The frictional force always all the time should be dependent upon the normal reaction force. But there is one important part. We are not saying that is F is proportional to the weight. Why? We will discuss that later on. But here what happens? F proportional to N, that means if I want to make it equal, then you have to provide one constant, and that constant here is equals to mu N. This is basically called as coefficient of friction. This is coefficient of friction. Okay, this one is called as coefficient of friction. That means the main equation is F is equals to mu n. So first of all we have to remember this, that is important. Now there are basically three terms. One is Fs, another one is Fk, and there is another one which is called as the Fr. Basically these three type of parts are there. What are these three? Fs, Fk, Fr. These are all frictional forces, but it is basically called as limiting static friction, limiting, this one called as static friction, this is called as kinetic friction or dynamic friction, and this one is called as rolling friction. Rolling friction. These are the three kinds of frictions in general we can be able to get. What happens when there is the sliding? When we are making this force, what happens? This particular object slides on this particular plane. That is the case. There is the sliding. So in case of the sliding, initially it can't be able to move. It will try to move in this direction, but it can't be able to move unless and until the amount of this force is more than the limiting static friction. That means the limiting friction which is provided by the surface on this particular surface to resist the movement of the body. That means this is the limiting static value, that is the ultimate limit up to which the surface will not will try to make the object totally at rest. That means this is the maximum amount of the frictional force the surface can be able to provide on the object. Okay, so we can say if this F is greater than, this F is greater than Fs, if the amount of the force which we are providing on the body, if that is more than the limiting static friction, then what happens? Then the body will now move in this direction, in the direction of the force applied. So that means if this one is there, then there is the activation of this Fk. So that means initially there is no Fk, but when the body now moves in a particular direction which is more than the value of this limiting static friction, then there is the application of the Fk. Unless and until there is the movement of the body, there should not be any kind of Fk. That is the main part. So what happens? So if K, obviously as the body is moving now, so the amount of the frictional force is little bit less than the amount of this Fs. So we can say Fs is greater than Fk. Obviously Fs must be, that is the limiting static friction, must be greater than the kinetic friction. And in general what happens, we generally see there is a wheel for all those cars and something like that. There is all where the wheel, basically they are circular in nature. But why circular? Because there is the part of the rolling of the object, and when there is the roll, and in that particular case the rolling friction, in case of this rolling, the rolling friction Fr is basically the least one. So this Fr is the least one. So there is the variation like this. Fs is greater than Fk and Fk is also greater than Fr. So Fs is the maximum and Fr is the minimum most. Now as this F is equals to mu into n, already we have seen. So we can write this Fs as equals to mu Sn. We can write Fk as equals to mu Kn. We can write Fr is equals to mu Rn, right? So from this particular relation we can write mu S greater than mu K greater than mu R. This is the another relation between the coefficient of frictions in case of limiting static, in kinetic and in rolling. Okay, so this is the relation we have to remember. Now When there is another part, we can say there is the force already we have identified that, and there is the weight which is acting in the downward direction. Now here we can say another thing, that means there is the weight. Okay, now there is the aim. If there is the force and there is the frictional force here, if I am making one resultant of this frictional force and the normal reaction, that means the resultant of this frictional force and the normal reaction, if I call it as R, say if I am making one resultant of this frictional force and the normal reaction, let us say the value of this resultant force is R, as we know. Now if I say the angle, the resultant force which is making with the normal reaction is say lambda, then what happens? R cos lambda is the component of this R along n direction, means R cos lambda we can call it equals to n. Obviously this one must be the first one, R cos lambda, we can say this is equals to n, and again we can say R sin lambda is equals to f. Obviously R sin lambda means this one, this is the component and this is the component R cos. So if I am making R sin lambda by R cos lambda, that becomes f by n, and as f is equals to mu into n by n, so you will have is equals to mu. So that means from this we can say tan lambda is equals to mu. This is one equation we can be able to remember. Tan lambda is equals to mu means here this particular angle is called as the angle of friction. This is called as the angle of friction. And there is one hypothetical one part is also there, which is also called as the cone of friction. The cone of friction means what? The cone of friction means if I am taking this particular resultant of this normal reaction and the frictional force, and if I am making one angle, say circular rotation like this, making this normal reaction as the axis, if I am making one say lambda angle, then rotation of that one three dimensionally we have to imagine with respect to the axis, which is basically the normal reaction force, then the cone, it will form one cone, right? This is the vertex, so this is the slanting side of that one, slant height of this cone, so it will form a cone, and that is called also as the cone of friction. That is one hypothetical one, virtually say one cone is there and we can see there might be one cone, and that cone has a special name we have said earlier, that is the cone of friction. Okay, important part is tan lambda, and this lambda is called as the angle of friction. Okay, now we are coming to one special case, that means here initially the object is on a plane which is horizontal. Now if the object is not in the horizontal plane, say the object is now in a plane, this block is on a plane which is not basically horizontal, but rather this one is making an angle theta with the horizontal. That means initially at rest or horizontal there is the plane, and on that there is the block. Gradually we are making some angle with the horizontal and making one angle say now theta, and there is also the object. The object is now in such a position on this particular plane so that it just tries, that is the important term, just, it just tries to move in the downward direction. It just tries to move, but it is not basically moving in the downward direction. Okay, now what happens again? Here obviously the weight is always all the time that must be vertical, and if this one theta, this is the normal must be always all the time perpendicular to the plane, always all the time. Then if I extend this one, if this one theta, then you will get this angle is equals to theta. Why? Because this plus this angle is 90 and this plus this angle is also 90, because this particular line is perpendicular to this part. So ultimately you will get this angle as equals to theta. It is a simple geometry, nothing else. Okay, then from this, if mg is this one and this one theta, so with which it is making an angle, that must be mg cos. So this particular direction of component should be mg sin theta, mg cos theta, this one mg sin theta. There is the n, normal reaction. And as the body tries to move in the downward direction, so there must be the frictional force in the opposite direction of its tendency of the movement. Here this one is not moving, but there is a tendency of the body to move in the downward direction. So here what happens, first of all we can be able to write this one as n is equals to mg cos theta. Obviously this one true, n and mg cos theta must be equal first, and f must be equal to mg sin theta, it must be equal to. Now what happens, as f is equals to mu into n, we should have mu n is equals to mg sin theta. Now if I make mu into n means mg cos theta, if I make this substitution, then you will have that is mg sin theta like this. From this mu becomes tan theta, from this mu becomes tan theta. That is the important part here. So now when the object is initially placed on a horizontal plane, then after a certain interval of time it is gradually, the angle is basically increased with the horizontal, and at a particular angle what happens, it tries to move in the downward direction, it tries to move but it is not moving. At that particular position, whatever be the angle theta, this particular theta has a special name which is called as the angle of repose. This theta is basically called as the angle of repose. This is the angle of repose. This particular angle has a special name, that is angle of repose, and tan theta of that one must be equal to the coefficient of friction between these two. Now here the important part is that n is now equal to mg cos theta. So initially we have said we are not saying f is proportional to mg. We always all the time say f proportional to n, because all where the n must not be equal to mg. Here this n is now equal to mg cos theta. That means as this one is inclined, so n now equals to mg cos theta, that is not equal to mg. So always all the time n must not be equal to mg, it might be different. So the constant part is n. So frictional force is always all the time proportional to the normal reaction, not the weight. Okay, this is the vital point also. Okay, now what happens, now a special part, say the weight of the body is such that now, say we have increased a little bit and this particular theta is now such that the object is now little bit, there is the movement of the body with an acceleration in the downward direction now. So now what happens, now this mg sin theta must be more than the value of this frictional force, and so there is the acceleration of the body in the downward direction. So there is now the Newton's force, laws of that. So equation, force equation. So we can be able to write this one as mg sin theta minus f. Mg sin theta is the lower direction force, f is in the upper direction force. So there is the resultant force is this, and resultant force is equals to mass into the acceleration in that particular direction. Already we know from the Newton's first law, okay, Newton's second law, sorry. So now we can be able to write it like this, mg sin theta minus f becomes mu into n again, but here n is equals to mg cos theta. We are writing this one now like this, is equals to n into a, like this. So we can be able to write a is equals to g into sine theta minus nu cos theta. So this is the part we can be able to provide in case of the movement of the body with an acceleration in the downward direction on a frictional surface. That is the surface which has a friction, which is a rough surface. So on that particular surface, if there is the movement of a body or a block in the downward direction due to its weight with an acceleration a, then the final equation we can be able to derive like this, and from that we can be able to identify the value of this acceleration. Okay. Now we can make another type of equation here. Say we have provided one force like this. We have say provided some force. Say this is the inclined plane, okay, on which there is the object and there is a force, say T, tension force we are providing on that, making an angle say alpha with the inclined plane, and this inclined plane is basically theta angle making with a horizontal surface. This one is making an angle theta with a horizontal surface, and there is one rope. With the rope we are making the tension, we are providing tension on the body, and this one is making an angle alpha with the inclined plane. Okay, now what happens? First of all, we have to make the components T cos alpha, and in this direction there is the T sin alpha. Always, all the time, this one is okay. We know this, that is the components, those are the components of the tension. Now there is the weight which is running again the same thing in the vertically downward, and there is the normal reaction force here which is acting perpendicular to the plane, inclined plane. Now again, if I am making this extension of this normal reaction direction, then this angle must be theta. So we can say there is the mg cos theta, and in the downward direction there is the mg sin theta. Up to this part, this one is okay. Okay, now say the object is now moving with an acceleration a in the upward direction of this inclined plane. It might happen we have provided the tensional force T such a way so that ultimately the object is now running in the upward direction. Say this one is running with an acceleration a in the upward direction of this inclined plane. Then what will happen? Say if this object is moving with an acceleration in the upward direction, then obviously there must be the frictional force which is basically acting in the downward direction. It will act in the downward direction here. So here in this case there is the downward direction force which is F. mg sin theta is acting in the downward direction, T cos alpha is acting in the upward direction, T sin alpha in the perpendicular direction of this plane, inclined plane. So we have to make the arrangement of the equation, that is nothing else but Newton's equation we have to derive from this. So what happens? Normal direction, all the forces must be equal and opposite obviously. So n plus T sin alpha must be equal to mg cos theta. That is the first part. N plus T sin alpha is equals to mg cos theta. That means these two in the upward direction, and lower direction or opposite to that direction there is the mg cos theta, and they must be balanced with each other obviously. Okay, so we can say n must be equal to mg cos theta minus T sin alpha, like this, mg cos theta minus T sin alpha. Okay, and in this direction, that means along the direction of the inclined plane, what will happen? There is an acceleration in the upward direction. So T cos alpha must be greater than the summation of mg sin theta and F. Obviously, in the downward direction of the inclined plane, there are two forces, mg sin theta and F, the frictional force. But in the upward direction of that one, there is the T cos alpha only. But as there is the acceleration of the body in the upward direction, so what happens? There must be T cos alpha
greater than the summation of this mg sin theta and the frictional force F. So how to write the equation here? It is nothing else but T cos alpha. First of all, write it down like this: T cos alpha minus, there is mg sin theta plus F is equals to m into a. That is the equation we have to write here. T cos alpha there minus mg sin theta plus F will become m into a. That is the final equation of the from the Newton's second law. So now from this we can be able to write this one like this: T cos alpha minus mg sin theta minus F means mu into n, minus F means mu into n means this one. So we can write, we just substituting this n, mg cos theta minus T sin alpha, that is this particular part is equals to m into a. That is the final part. So from this, if you want to identify the value of this a, say, then that becomes, just you have to make this summation in a proper way. So that means we can write T into cos alpha plus mu sin alpha, taking T as common from these two. Then again we can take minus mg as common, sin theta plus mu cos theta and whole divided by the mass m. So here in this particular case we should have the acceleration of the body in the upward direction as T into cos alpha plus mu sin alpha minus mg into sin theta plus mu cos theta, whole divided by the mass of the body, and you will get the acceleration of the body in the upward direction along the inclined plane. Okay, so more or less this is the total part of the friction, and when we go to the problems of the friction, then these particular applications of these theorems will be much more clearer. Okay.